Welcome to Beyond Tech, where innovation meets insight. I'm Jackie Slatt, Director of Marketing and Communications at eTech Group. Manufacturers today are investing heavily in automation, from advanced laboratory robotics to highly automated production systems. But while individual processes may be optimized, many organizations still struggle with a bigger challenge: connecting those technologies into a unified operation where data, workflows, and decisions flow seamlessly across the business. Today, we're exploring how laboratory automation and industrial robotics, or LAIR, and manufacturing execution systems, or MES, work together to break down those islands of automation and enable truly intelligent manufacturing. Joining me are two experts who bring complementary perspectives to this conversation. Sura Hadi is our Director of Lab Automation and Industrial Robotics, and Leong is a Principal Engineer at eTech Group with extensive experience in MES and digital manufacturing solutions. So Sura, Chris, thank you guys for joining us and welcome to the podcast. Thank you.
Glad to be here.
Thank you. I'm always so excited to talk to members of our team. And Sir, I know you've been with us for a couple episodes, but Chris, this is your first episode, so welcome. Before we get too far into this, can you guys give me a simple definition, or in simple terms, what lab automation and industrial robotics is and what MES is?
Sure. So we use the acronym LAIR. So we do laboratory automation, informatics, robotics, and robotic systems. And I guess the simplest way I can describe it is that, LAIR is everything that does the physical work in a lab. So the liquid handlers, analytical instruments, the robotic arms, the plate movers, the transport layer that carries a sample from one station to the next, and the schedulers that decide when which arm moves. So we basically live at level like 0 through 2, if you think of it in ISA 95 terms, and that's the equipment layer and the control layer. And MES sits above that at level 3. So the analogy that I use with clients is LAIR is the hands and MES is the plan and the memory. So we know how to run the assay, but we really need to make sure that we work together so that it can happen in a way that the business can use.
Chris, do you have
Yeah.
anything to add?
Yeah, and I'll add to that, just basically in terms of MES, right? I always think of it as software, referring to that S95 kind of structure. It's a software that bridges the gap between high level business strategy, right? You're talking about your SAP ERP and your physical shop floor automation. Really, it could be something as simple as making paper manufacturing, all the processes that are, done manually and done by hand and recorded on paper, and then transferring that into an electronic process.
What would you say manufacturers commonly misunderstand in the roles of lab automation and then MES?
I think that manufacturers, when we talk about MES, a lot of times it seems like it's too broad of a term and think that it can do a lot of things, maybe too many things. So I think that in terms of what manufacturers want to get out of an MES, right? Do they just want it for weigh and dispense? Do they just want an electronic batch record, something to track hygienic states, right? I think that manufacturers misunderstand maybe what they want to get out of it in terms of what their scope is for implementing that system.
And I think for us, the biggest misunderstanding is not really knowing where the lab to manufacturing interconnectedness is, right? We really have to break out the fact that, what we're looking at here are manufacturing solutions that work for what they want to do, but they're not work cell schedulers, right? For the work cell schedulers, the automated lab always has some kind of orchestration software that's sequencing instruments, and people assume that's their execution system, and it isn't. It sequences equipment. It doesn't own batch records. It doesn't track material genealogy. It doesn't connect to the business. So that's one confusion that's caused more failed projects than any other technology gap that I've seen, is just not knowing where these two sit and how they come together.
What would happen for a manufacturer if their automation advanced faster than the execution system, or vice versa?
So I think you're talking about when automation maybe outruns execution, right?
Yeah. Yes.
Okay.
Sorry.
Yeah, no worries. You don't get speed, obviously. You just get like a faster way to build a backlog, I think. And that's like one pattern I at least see consistently. I don't know, Chris, if you can speak to this, but say a lab triples its instrument throughput and everyone gets super excited, but then the bottleneck just moves, right? It relocates. Now we've kind of diverged it from that hurdle. We put it here, and it's the scientist sitting there in the evening transcribing results to a spreadsheet because nothing downstream can consume what the instrument just produced. For us, we can deploy LIMS solutions to orchestrate and automate that, But, if you deploy a full MES and the instruments aren't connected to it, you bought a very sophisticated data entry application, is what I would say. And so what happens next, you can kind of predict operators start going around it, right? They keep their real records somewhere else because the system's making their day job harder instead of easier. And then you're right back where you started. So the framing now is off. And that's important because when you say infrastructure first, AI second, you've lost that real connection to enabling that. What do you think,
Yeah,
Chris?
and to add to that, I think what you're talking about and what I see a lot with customers is the idea of like islands of automation, where you have a lot of these very well adapted systems for lab systems, right? That are really great at what they do, but if you can't capture that data and send it over to say your MES or some other kind of data lake to then contextualize and interpret that data, or if the process to get that data is very labor intensive, then you lose a lot of efficiencies there. I think going back to the original question of how I interpret when technology advances faster than the current systems that are in place is what I see with a lot of customers in terms of, okay, they already have an MES, maybe they already have their DCS, distributed control systems, or process automation systems. And we run into something I like to call upgrade burden, where a lot of these systems are in dire need of upgrading, haven't been upgraded in maybe 5 to 10 years, but because these systems exist in a manufacturing 24/7 site, they
There's no
don't have
break.
enough, there's no break. Exactly. And so, due to that, are faced with this upgrade burden where, vendors and as a company, eTech, goes to those customers and say, hey, we really need to get in there, upgrade the systems so that the system has the necessary protections it has for security and has all of the most up-to-date features possible that are offered from the vendor.
Yeah, so you touched on the islands of automation. I think that's something that we've heard not just necessarily in any one environment or industry. It's kind of across the board. So what are some signs, I guess specifically in a lab or on the production front, that they may be running into these kind of islands of automations?
Yeah, it's interesting because that's another trendy thing that folks say, right? Like islands of automation. And sometimes, it's a positive where you build like logistical work cell stations. And so it is an island because it's a work cell logistical station. But really where I'm encountering is, if the person is the integration layer, you already have islands, right? So what Chris was talking about, USB drives and CSV exports moving between instruments and a PC sitting under a bench, running an operating system that hasn't been supported in years because that's the only instrument driver that it will run on. Scheduling is being managed in a shared spreadsheet. That's where you should look and say, hey, you know what? That's a problem. That's one engineer, one scientist, and there's only one person that can run or modify that method. So organizations tend to describe that person as like an asset. And, if that person leaves, everything falls apart. But that's a risk because now you're trusting that person to be the integration layer. So that's where, we come in and we try to liberate that so that nascent knowledge isn't just one person. We've automated the entire process so that now your system can work in conjunction to become the full integrated automated solution that you're looking for. And the gap between the local performance and the system performance defies that definition of an island because now everything is connected. So every instrument has its own login, audit trail, clock, and everything works together. And that's really important to fix at the outset because it's very hard to fix retroactively, right? Especially in areas that Chris was mentioning that are running 24/7, or how we're moving now where they want labs to be lights out facilities, right?
Yeah, I definitely agree with that. We want to try and prevent as much as possible, the operator or the worker in the lab getting that sample result and then writing it down on paper and then running it all the way back to the manufacturing floor to hand it off to that operator. That's not the ideal situation that we want to run into, in preventing these sort of islands of automation.
Well, it's
Yeah,
interesting. I
that's
was at a cable manufacturing company and it's literally dripping clipboards like with water that they were trying to keep track of. Like, this is never going to work.
so anytime that you're kind of relying on a manual process of like either moving information, kind of transferring it, that would be a sign, I guess, that you're something's on an island because there's you're relying on human transfer of information or processes.
Yeah, yeah, exactly. Again, it could be something as simple as someone writing down values on a sticky note and running it over, or, putting it into an actual batch record and then having to pass that physical paper over, versus having these connections through any kind of these open communication protocols like OPC, or, talking about like REST API, MQTT, to connect like limbs to MES or other systems wherever necessary.
Yeah, the best that I've seen, and my scientist colleagues can probably feel this, is writing it on the back of your glove and then realizing like you have to leave the lab. The glove has to come off.
So
Rather than
that
to
kind of
spray
leads.
some IPA to sanitize your gloves again, and then, oh, well, there goes the sample results.
We want to avoid that.
We can make that process better. So what data gets lost, or is it never captured when systems aren't integrated?
I could go first here. So what I see when, you do have those operators writing data on sticky notes and, their gloves, and something that isn't digitized, is that we lose the ability to track this data, right? We lose the ability to have all of this data, like, time that the sample was taken, time that the sample was received. And if we don't have that data, then we can't create metrics and trends out of that data to then increase our efficiency, right? Analyze some of those trends and say, oh, okay, like, why did it take like an hour for the operator to go from like the manufacturing floor, like collect the sample, all the way to getting into the QC lab? How can we streamline this process, make it easier for the operators and everyone involved to streamline that process, right? If this was a completely manual process where everything was written down and instead of digitized, then we wouldn't be able to go in, analyze that data, and troubleshoot.
Yeah, and I think just to build on that, a number's a number, right? If you don't have context, you really lose everything that you need around it. And it's not even that data is getting lost. Some data is never even captured, and that's really important. For us, the instrument state, the calibration status, which lot of reagent or consumable was used, even which tip type, environmental conditions, whether there was a deviation, and the operators, like who touched what and when, right? And the first thing that disappears when we see this is not only that that data isn't captured, is that the exception data. A lot of systems that are deployed don't capture that. They don't capture reruns, aborted runs, error recovery events, and that's some of the most valuable information in the building. That tells you where your process is actually fragile. If we're deploying a system and we want it to be a robust system, you need that information because these consequences show up later when you don't address them, right? The result may not be reproducible, and it definitely isn't going to be comparable or comparable across sites. So you can't really scale a method. And the second one, and this is the one that, the pain is real, all that historical data turns out to be unusable when you want to train something on it. So everybody wants to apply AI to 10 years of instrument data, then they open it up and find the numbers have no context attached. So that's a real issue right now. The good news is there are real standards for this, right? SILA 2 for instrument control, OPC UA with the LADS companion specification, and allotrope, ADF, and ASM for analytical data, and FAIR principles as the philosophy underneath. So none of this is theoretical anymore. We just have to make sure that we are capturing the information we need so that we can train our models later.
So I want to kind of continue on this, what gets lost in the impact of it. So I know for specifically life sciences, the compliance, traceability, quality, all of that is, I think, hugely important. So not having the lab and MES working together and integrating, what is the impact of that?
Yeah. So I would say, or we have a saying in life sciences where if it's not written down, it's not recorded, didn't happen, So in terms of this data that we collect from, both the manufacturing floor and in the labs, right? We need this data in order to track trends, to estimate timelines, and, in the case of an audit, be able to produce batch reports to present to auditors to show hey, this is the complete record of what happened during the batch. We account for any of the deviations that came up, can explain ourselves in terms of any situations or, CPPs or CQAs, critical process parameters or critical quality attributes, that were, kind of out of range, able to explain that situation in the case of an audit because all the data is there.
Yeah, and I think the manufacturing space is a lot more, I would say, there's a lot more parameters around it than the lab automation space. We're kind of the wild, wild west out here. It's like there's unversioned scripts sitting somewhere. Somebody's notebook becomes like a production dependency. It works. Nobody questions it. No one approved it. No one tested it. Right. And so, we call this like shadow automation, things that happen, but no one really understands how to recover from it or where it's backed up or anything. And these things get changed, and they get changed without change control. And because the instrument software isn't making it difficult to do that, it's making it pretty easy. It's opened, right? The scientist just adjusts parameters and moves on, and we don't capture that. So a lot of the processes that we put in place are making sure there's change control, there's audit trail, there's an ability to really abstract away what the operator does so that everything else in the background runs and can be compliant. And that is the biggest thing that we're finding now. Our labs are trying to move into GXP environments, and they don't have that structure in place. And we really need to engage to make sure that they understand, they know what they don't know, right? And so we can go ahead and work together to make it compliant, basically. The A in Alcoa Plus, right? Attributable.
So I want to keep talking on this because I think it's again so important and so crucial to every part of this is the just the data that you can get from all of the equipment and what you can do with it. So what role does MES play in orchestrating automated workflows, or what role could it play?
Basically, like I said before, MES has a lot of moving parts to it, right? But I think that the one part that most customers are concerned with here is that of its heart and soul, which is an electronic batch record, right? And so when we talk about orchestrating automated workflows, the idea of this electronic batch record is to be able to execute that batch record, that recipe that the customer has electronically to make sure that all of the steps executed in it are executed properly, are attributable to the operator that performed that step, right? In the case that certain steps need a verifier as well, additional person to go in and make sure that the work that was done was performed correctly. Is all captured within that electronic batch record. So when when we talk about orchestrating automated workflows, it's that electronic batch record that is at the heart and soul of this idea of MES, manufacturing execution system.
So one of the things, Sarah, you mentioned earlier is how lab automation kind of stays on levels 1 and 2 of the technology stack, and MES is on level 3. So I feel like it's really in this connection layer and bringing everything together. So how can it improve the decision making? How can MES improve the decision making for operators, engineers, and then even leadership?
Yeah. So in terms of MES, right, since it is able to collect all of this data and you're able to analyze it and make trends, right? This integration, it helps us prevent data from being lost. In terms of efficiencies, it promotes a Six Sigma in terms of capturing efficiencies and tracking trends, right? Where we can analyze how long certain manufacturing steps might take and trend that over a long period of time and see, oh, okay, like this one step of the recipe is taking, the most amount of time from an operational perspective. How can we improve this, right? And ask kind of the right questions by interpreting this data. And that only comes from integrating with other systems like LIMS and like the PAS or DCS, distributed control system, process automation system. And, the other part of that is that it also reduces the burden on operators and manufacturing personnel because it reduces the need for manual readings, right? And those manual readings are now automated and tracked in the MES and are then free to have calculations performed on them versus if that were a manual effort, right? Or if a sample result were received from LIMS, right? The time that it takes to communicate that via paper and via personnel, right, would take a little bit longer, I would think, than an electronic message, right? Electronic communication from LIMS over into MES. So it saves time and promotes efficiency.
Yeah, and I just want to kind of go down this rabbit hole because I think, the one thing I want to say is limbs is where Chris and I overlap, right? It's where most organizations have unresolved argument they never maybe said out loud. The mental picture here is that limbs may sit underneath MES, right? That's where people kind of assume. But there really isn't that disconnect. That limbs and MES both live at level 3. They're both peers sitting side by side, and that's exactly why they collide, and LAIR sits kind of underneath both of them doing the execution. So the question isn't, which one's on top or who owns what. It's people need to understand that it's one system of record per object. So the sample belongs to LIMS, the batch or the order belongs to MES. And so the method running on the instrument that LAIR oversees, if any single object has two masters, you kind of have to have a reconciliation problem, right? And that shows up in very recognizable ways where sample IDs don't match between the systems. And if a result exists in two places with two different statuses, release waiting on a person to referee which version is true, that's where you end up having a problem. So I think the handshake is that results flow up, authority flows down, MES triggers a sampling event, LIMS owns the sample through its whole life cycle, and it owns the result. So the lab instrumentation executes and returns that result with all the context that you need. So that's a good way to think of LIMS and MES because we both touch it from LAIR and from MES.
That was great. I was going to go to a LIMS question next. So, sir, you beat me to it. So I want to just again, kind of hitting on this, the importance of the data. What's the difference between just collecting a bunch of data and making it operational and being able to make operational decisions with it?
Gosh, I bet we both have things to say about that.
Probably.
I think you can collect a bunch of data, but if you can't find it later, what's the point, right? So operationalizing it, I think means, you have something you can act on without a human in the middle. And that's the context again. And most organizations I walk into have what we call kind of like a data swamp, right? It's full of PDFs and instrument exports. That's storage. It's not really infrastructure. And nobody's going to make a decision from that. They can't. And the speed of the process actually interrupts what the client is trying to achieve. So when you think of operationalized data, it's structured, it's contextualized, it's time stamped, and it's delivered to a consumer that does something with it, right? So a scheduling decision, a hold, a release, a retest, a model. One thing I ask clients is, can a downstream system act on this record without a person rekeying it or reformatting it or interpreting it first? If the answer is no, then you're collecting, right? You're not operationalizing.
Yeah, and I'm aligned with everything you said, Sura. And to that, I think you also touched on it earlier, is that a lot of times in kind of what you call like this data collection swamp, a lot of times it's not labeled. There is no context for it either, where if we look at the database tables that some of this data sits in, maybe there aren't columns for calling out, oh, this sample or this sample value was for bioburden, or this other one was for endotoxin. And it just literally has a value of like 4.5. What does it mean? We don't know. And so that's an issue when we talk about operationalizing and contextualizing data.
Yeah, good luck. Maybe there's like an instrument attached and you can kind of figure out what that instrument does.
I'm picturing the reverse clue where you've got the answer, but how did you get here?
Yeah, a lot of my colleagues who just deal with data, or that's the first thing they need to do is make sure that your data is tagged correctly. We need to be able to figure out what the context is.
I want to shift gears a little bit, but why do pilot automation projects often stall when they're trying to scale?
I think this is an interest because pilots usually succeed for the reasons that they don't run surprise when the pilot doesn't scale. And you got to kind of step back and think about the conditions where you're running a pilot, right? There you've got one skilled operator, usually the person who built it, one instrument, curated samples, no change control. And each one of these things disappears in production. Because none of them were written down as dependencies, no one kind of gets alerted, right? So that's one thing. And then the second reason is budget. And that's the one I'd really like highlight and underline. Nobody really funded the integration layer. So instruments and robots get capital approval fairly easily because you can point at them. You can say what they are and what they do. These interfaces, these drivers, orchestration, data plumbing, right? Those rarely have an owner and almost never have a budget line. So the thing that undermines whether it scales is the thing that nobody really paid for. So I think that's an important distinction. And the third is validation sort of gets deferred because it's a pilot, which seems reasonable at the time, but that means the pilot can never really be promoted, right? You can't validate your way backwards into a system that was built without any of the documentation that it needs. So then you rebuild it and it looks like the pilot failed when really it was never designed to survive because of those three conditions. So usually what you want to do is make sure that if there is no user requirement specification, there's never an agreed definition of what success at scale would even look like. You can't hit that target, right? It's like you can't hit a target nobody wrote down. So the pilot really has to be representative of what it's going to actually look like. And those things are almost never accounted for, probably because someone wants to sell you something. So these are good questions to make sure that you have at hand so that it actually succeeds when you put it in practice.
And I'll add to that, there are a couple of questions that we should ask or the customer should ask themselves before they break ground on the pilot plant is, what are your requirements? What do you need in terms of automation? What do you need that automation product to do? How many vessels, how much equipment are we installing here, right? Like Sura said, did we take into account the validation situation? Is there proper risk assessment done? These are all questions, addressing the why did the project stall that were not asked at the beginning of the project.
I think it's also important to think about, what do you want that long-term solution to look like, right? I've seen a lot of clients that buy a system that worked for exactly what they bought it for. But as you know, science evolves rapidly and it changes. And if that system can't be modulated enough to shift and get reformatted to your new assays, to your new science, then you just, sunk $500,000 in something that ends up holding cardboard boxes, right, for the rest of the lab. And that's not where you want to end up either.
What should a client be looking at? What standards, interfaces, or what are some best practices that they should be paying attention to avoid expensive redesigns later?
Yeah, from the MES and automation perspective, right? We want to try and adhere to the S88 and S95 structure and hierarchy as much as possible because that hierarchy gives us those guidelines of how data and processes should be carried out throughout from the control level to the batch layer to the MES layer to the ERP layer of how the data should flow and which layer is responsible for what. As long as we keep the boundaries set there and establish the responsibilities, that will help out with future success. As it pertains to MES specifically, suggestion that I have that, maybe many customers would like to argue with is try and implement COTS or commercial off the shelf as much as possible, right? Maintaining that COTS functionality will help with support in the future from the vendor as much as possible if needed. The more custom implementation there is at the site for a project, the harder it is for folks, for tech, for vendors to come in and help because they need to get familiar with the custom implementation before they can ramp up and then contribute to the project.
Yeah, I think that's great. I agree with the custom automation part because I come into a lot of clients that have homegrown limbs, right? Or they have one engineer who decided to build a robot for them. It's just not sustainable or, you can't really support it. You can't upgrade it. If you do those kinds of solutions, work with a known vendor or partner like us, because then you're future proofing your entire, fleet or your software. You're kind of adhering to the right requirements and standards that we have in place. Homegrown really becomes you outpace it very quickly. You outgrow homegrown pretty quickly.
How do you future-proof compliance as automation technologies evolve?
So I think we touched on it before. Ensure that we are 21 CFR Part 11 compliant right? Use softwares that have this functionality supported. What that means is from a regulatory and audit perspective, right? Software needs to be able to retain records and to be archived. Those records that we have stored in that software need to be complete, and humans need to be able to read it. When it comes to users accessing that system, that the permissions that are in that software got to be role based so that all the users are part of certain security groups. And that's very easy to manage from an IT perspective as well as from a security perspective. I could go a lot more into that 21 CFR Part 11 compliance bit. I'm sure a lot of folks in the industry have heard an earful of it, but that's, one of the main things that I see is, around that security portion, around that 21 CFR Part 11 compliance.
So your question is future-proof compliance as technologies evolve, right? I think the important part is again to take a step back and validate the process and the risk, not just the information the vendor gave you. And for that, really like the GAM5 aligned approach and making sure that you're bringing that computer software assurance thinking into your testing effort. And that actually follows for some clients that this is relevant to patient and product risk instead of page count. And a lot of organizations are still generating enormous validation packages that don't really reduce risk. They just document it. So I think that audit trail has to be built into the system, not kind of attached as a document trail afterwards. So you have to think about that at the beginning. And system generated beats manually maintained every time. So in front of an auditor and in reality, that's what they prefer, right? So you have to make sure that you've got that in place.
So I guess something that is important to, I think, every manufacturer is what is the ROI on anything. So aside from labor savings, what are some other ways that somebody could look at the ROI on LAIR or MES or both?
I think for LAIR, it's interesting because, they bring us in to make the most of their workforce. So labor savings is usually what gets communicated as the need. And it's potentially the weakest argument in the room, because I feel like it's much more important to really think about not something that makes your own scientists nervous because you think they're going to be displaced, but how do you launch a program and what does that mean for your return on investment? The strongest things to measure or the stronger things to measure are your time to decision. How does this ensure that you are bringing a product to market faster because you're generating enough data, you're analyzing it quickly, you're using, very intelligent approaches and models to get that data. You've looking at cycle time as well, the cycle time to result, right? And the capacity created without new capital, just with what you've purchased, right? And I think the most important is rework or repeat run rate. All of these things actually speak to the business and to getting that answer sooner. And that's something that I think finance is much more interested in. And it'll ensure that your team feels like they can vet and buy into this process because, they're not worried about their own job security. There's a whole new category of people, right, that are in the room. And there's a lot of deviations that are avoided when you put automation in place, which is also a quality and compliance value.
Yeah, and I'll add to that, right? If we're talking about ROI, it's more than just the monetary value. It's, the quality of life of being able to have an electronic process and save time, not just for operators and in terms of labor, but also in terms of analytics, right? If I want to get specific here in terms of, if we have a group at a kind of customer site that has an MES and is doing these analytics using the data, manufacturing data and analyzing the trends, right? Specifically, maybe there's some way that they could save on energy costs, hot Wi-Fi or what we call water for injection, right? Maybe there's a certain point at which the hot Wi-Fi can be lowered, or maybe they only have to have it at temp for a certain amount of time. Maybe through the trends, we can see how certain manufacturers have higher failure rates for certain lots, right? Maybe we can analyze some of the trends for equipment to have more predictive maintenance. Maybe we analyze some of the trends for, say, what we call TFF, tangential flow filtration, and seeing that maybe some of these brands of filters are failing more often, or maybe, on this shift, the filter is failing more often. And then we kind of delve deeper into, what the root cause is there. So, when we say ROI beyond the labor savings, it's, a lot of these analytics that we can run and efficiencies that we can capture that way.
That's actually a good point because I think it's important to note that, this helps us understand what a lost batch actually costs and what a failed audit costs. Those are numbers that executives are very aware of. They're less skeptical of those than they are to like efficiency claims that you might make. So I think that's something that is a real tangible thing that you can reap ROI from. And scientist retention is one I throw in because I've heard this a lot. What percentage of a PhD's work is spent doing work that only a PhD can do, rather than just feeding a robot a plate or manually moving water from one tube to another, water being the sample, right? So if
Well,
you
I
hire
thought
someone for their
outplotting was every
judgment,
PhD's favorite thing to do.
yeah, right? I've just gotten a lot of those where you're hiring someone for their background and they're spending all their Thursday moving plates. That's a measurable loss, right?
Well, this was a super fun conversation. I feel like I do always learn a lot, and I would say MES and LAIR are two areas that I still have a long way to go, but I appreciate you guys talking with me and sharing some insight. Before I get into my closing fun questions, I am wondering if you guys can think about and share a project that changed how you think about automation and integration. Sorry, I know that's kind of a tough one to just throw out. But
I feel like all my projects make me think a little different. A lot of things that, reset our thinking are just the new trends and advances that not only are made in science, but in lab automation, in robotic systems, in, AI and how it's being applied to these processes. Large discovery platform programs always challenge us on that front because they've got a layer of, instrumentation, transport layers, orchestration, more than a dozen workflow. And I think most people assume the hardest part is the robotics, right? The motion, the mechanical design, making the arms more reliable. And that work is real, but it's not what consumes the effort. What consumes the effort is this interface definition. Which standard are we using at each boundary and who owns the layer between the scheduler and the execution system? What happens on an exception, right? And who's responsible for the recovery path? Those are the conversations that determine where the program worked. And I think that was the shift for me, is to ensure that you don't treat integration as the last step of a project, the thing that you do after the equipment arrives. You start treating it as an architecture. It's the first decision, right? Not the last one. So I think that's really important. And you see that in a lot of these projects. So it's hard to capture one, but I would say that's the like message.
that's great. Chris, do you have one?
Yeah, for me, it was a project when we were integrating an MES with an ERP. What I really found from this project is that even past the lines of code and all of the object that we configure, and we are working with software and computers firstly and foremostly, but behind all of that, there's a real human element behind all that automation. So even though, again, working with all the software and code for this project, we were interfacing from our MES team with the ERP team to make sure that the configurations were correct, that we were getting the data communicated and all the messages synced. It was someone else on the other side. So, what I would say is that not to lose yourself in like this whole idea of like AI and, highly automated systems. There's a real person that's driving or set up those configurations and those transactions in the first place, through all of the working meetings that we had with the ERP team and our MES team. That was what it took, so ultimately it was a lengthy process and many hours, but I learned that there's a real human element behind all of these lines of code and automated processes.
Yeah, that's great. Okay, so now I have my fun closing questions. So thank you guys for joining us, and I will make these quick. What is one piece of advice that you would give to someone who's just entering the automation field today?
For me, I say, lab automation, and that's what makes, my group so interesting, is there's a lot of different aspects, right? There's instrumentation and controls, there's informatics and data architecture, and then there's just actually going in there and looking at the scientific assays and being a liaisons with the scientists. So anybody entering this field, just be curious and ask questions and chase your passions. And, whatever you are interested in, there's something in lab automation and industrial robotics that's of interest to you. The informatics field has multiple layers within it as well. So definitely reach out if you have any questions to us at eTech. We have internships going on, and just in your own life, chase your passion, I would say.
Yeah, I would say, any experience helps, right? Internships, co-ops, past that, I would say build your network, via clubs or professional organizations. They are your support that can help you. If you have technical questions, they can provide opportunities, and vice versa. You might be able to provide opportunities for them as well.
That's a good piece of advice, I think, from both of you. So last question is, what's one trend in automation or manufacturing that you are really excited to see kind of where this goes in the next couple of years, maybe months? Sometimes it moves fast. So usually it moves fast.
Yeah, I think we touched on it a little bit today, but I would say AI is the hottest topic
Yes.
in the world right now. As it pertains to MES, I would say most exciting is for recipe development and SOP development. Having kind of a integrated AI agent for a customer that knows all of their procedures, knows all of their processes, right? And is able to help engineers build out recipes and build out objects, reducing a lot of the manual labor and allowing them to utilize their skills to the best of their ability.
Sure. I think there's a lot of things that I'm excited about. I'm very optimistically cautious about all the trendy things that are happening now, having seen laboratory automation from its inception to what it is today. I think the thing that is interesting is most of my career, I've seen that connecting an instrument meant a custom driver every time. So 20 instruments meant 20 bespoke integrations, and every one of them was sort of a maintenance liability that broke the next time someone pushed a firmware update, let's say. So that's not really engineering, that's just paying the same tax over and over again. And what's changed is we have, SILA 2 and OPC UA and LAS companion specifications, and those are now real. And vendors are shipping against them, and buyers are writing them into their purchase specifications. So that's exciting. And Altrope is doing the same thing on the data side. So the integration layer is slowly becoming a product instead of a project, which I'm excited about. And that's exciting because AI in the lab absolutely depends on it, right? You cannot orchestrate what you can't control programmatically, and you can't train anything useful on results that arrived with no context attached, like we talked about earlier. So every one of those interesting applications, the self-driving labs, the closed loop experimentation, adaptive scheduling, this is all sitting on top of this unglamorous plumbing, right? So that's what I'm excited about, is the thing that makes demos real. And it's consistent with how I sort of talk about all this. Infrastructure first, AI second, right?
Yes, we have heard that as well. It's very important. So that is all the questions I have. Is there anything else that you guys want to share before I let you go back to your real life?
No, this is exciting. I think I've looked forward to a conversation between LAIR and MES because we do flow and play in the same playground. And hopefully this conversation helped people understand where the differences and where we can leverage each other are.
Yeah, I'd
No.
agree. This was insightful and exciting.
Well, thank you guys. I will let us get back to it. So thank you. Thank you for spending time with us.